So let's take a look at our boxes here at the end. I highly recommend that you take these very seriously. So ask yourself what you take away from this lecture and just summarize 2-3 points what you have personally learned, and then make sure that you understand what you don't know yet. This will help you a lot when you study, and it will help you a lot to clarify your questions. In fact, you probably should also think about what you want to do to get more clarification. Because ultimately, our ultimate goal here was to use and understand a few concepts. And let's go through them and check them off if we can. So do I master my geometry and sine and cosine? I believe we do. I definitely know how to use the trigonometric laws properly now. That is what we covered in the first part of the lecture. And I know how they apply to physical systems now, right? So this is something where you don't just do A, B, C or alpha, beta, gamma. You now have to actually arrange them according to a physical system that's given to you. But I believe that was shown properly, so we can check that off as well. Now, the basic 2D vector operations have been explained to me, so I think I can check that off as well. And then I want to, of course, be able to differentiate which technique is better for which problem. And this comes really a little bit more through different homework assignments and so on, and you have a chance to practice that, but I think I can check that off too, because we talked about in which case one is easier or better suited than the other. The similar triangle method is very important for me here, so that is something that engineers need to master. Again, you have that in lecture 0 already listed if you need to read up more on that. But that is something I definitely master at this point. And of course, I know now how to physically implement all these concepts. So that means we are now ready to take a look at the homework. So let's take a look at the homework problems, and let me give you some clarification here, because often some of these can be tricky depending on the variables that you use. So let's go through them one by one. So here you see the trigonometric laws. Right, that is what you have to use here. Yes, you can solve this with vector decomposition, but you would get 0 points if you do that. So please use the trigonometric laws. Now, what I want to alert you to is the fact that F2 and beta are connected to each other, and that F1 and alpha are connected to each other. So often students come to me and they tell me, hey, my beta is actually larger than my alpha. What should I do now? This sketch doesn't make sense. And that's not true. The sketch still makes sense. You just have to redraw it. So in that case, if your beta is larger than your alpha, then your F2 moves up and your F1 moves down, and you can still solve it. Of course, you have to use a little bit different algorithm than some of your colleagues or classmates who have different variables. However, you can still solve it. The best thing to do for all of these problems is anyways to draw a sketch that is true to your variables. And I'll be very honest with you, with so many students in this class, sometimes it's not possible to have all variables match to each problem. So that means that sometimes there's a problem that you may not be able to solve. That is not the case for this problem. Everybody, no matter what the variables are, will be able to solve this. But I will show you later that this can be the case, and I will tell you what to do then. However, for now, please understand that you have a relationship between F1 and alpha, F2 and beta. Let's take a look at the next problem. So here I think it's very clear that you have a force along the x-axis and a force that is in the second quadrant, and all you have to do now is find the resultant, and look that here you are not required to use any specific method. Use whichever method works best for you. I recommend that you use the one that is more difficult to you, right? So often students tend to do the one that is like faster or the one that they are familiar with, but that is not the way you should study. You should study such that you use the method that is difficult, because you don't want to be faced with a difficult problem or a concept that is difficult to you when you're in an exam. And that's when you have to do it. You have to use a specific method. So when you have the choice, I recommend you always choose the harder one. All right, let's take a look at this one. So here is a trigonometry problem. You are required to use trigonometry, and then use vector decomposition to verify these results. And many times students come to me and say they don't match, what should I do? It's really not correct. And you have to be careful here because, first of all, if your alpha plus your gamma is larger than 90 degrees, the sketch is not true anymore. So if alpha plus gamma larger than 90, then you need to redraw. I mean, you should always redraw, but in this case, you definitely need to, because otherwise you will get super confused. Because if this is the case, that means that effectively your vectors are looking like this, let's say, and so your resultant force would go into the third or fourth quadrant. And so that is when it becomes really difficult to use the sketch that you currently see there. So please keep that in mind. And then also, sometimes there's something called the ambiguous case when you use the trigonometric laws, when you use like a triangle. There's when you use the cosine law, I should say. So there's the ambiguous case, which can give you very difficult time that really depends on your variables, what your f2 and your alpha is, and so on and so forth. But you will have to write that in this case you cannot solve it because of that and that. So you have to provide an explanation, and you have to then explain which method you trust, the vector decomposition or the trigonometric law version. So that was that problem. Then here we have a vector problem where you need to determine the angle such that the resultant force is directed along the positive x-axis. So that is something that prepares you for the future. We have not talked about this specifically in this class, but we want you to think ahead, and we purposely don't give you all the information, but what we want you to do is find this angle that makes sure that the resultant force of these two is acted directly along the x-axis. Once again, depending on your variables, there are cases where it's not possible to solve this. And you have to explain that in words why it's not possible to solve this if this applies to you. The majority of you will, however, be able to solve this properly based on their variables. All right, last but not least, we have these problems here waiting for you. And I think the only two I need to talk about is probably this one up here. So notice that we have a force that is pulling up, and this force is F1 plus F3. And you need to define FB and FA so that equilibrium is really created at that point. So we want to balance FA and FB by that force. And I believe that should be manageable with what we talked about in this class. And here, don't be fooled. I mean, the idea is, of course, to put you into like a little thinking pattern, but the only thing you have to do probably is turn your page here and look at it in a different way if you want to solve this problem. Other than that, I believe we're now well prepared and we are ready to tackle our first real engineering mechanics homework problems and enjoy the vector application and the trigonometric law. I wish you good luck with that, and I'll see you in the next lecture.